Hey everyone, this video is going to be going over how to solve rational and radical equations. So we're going to do this kind of in two parts. The first part focusing on the rational equations and then the second part on the radical equations. Alright, so let's get started. Well, first of all, what is a rational equation? Okay, so basically a rational equation is essentially a fraction. It's an equation that has a fraction in it. So let's kind of look at an example of what one would look like in that format. So if I had something like this, then, oh, messed up there just a second. Hold on, let me put the T there instead. So if I was solving this, the reason that this would be called a rational equation is because, oh, didn't want to do that, is because it has fractions in it. So I clean this up a second, got a little bit carried away there. All right, so you can see we have fractions. Well, to solve rational equations, what you want to do, you basically want to fix the problem where you don't have to deal with the fractions. And the way we do that is we try to identify what is the least common denominator. So the least common denominator, in looking at the different parts that I have here, here, and here, I'm trying to figure out what is something that each of those would go into. Well, before we deal with all three of them, let's focus on the 4 and the 5 first. So a common denominator, or a least common multiple, sometimes as it's called, of 4 and 5 would be 20. And the reason why is because both 4 and 5 would go into 20 evenly. And that's the lowest number where both 4 and 5 could go into. So since we know what it is for 4 and 5, well, now let's put back the t there. So what's the least common denominator of 4, 5, and t? And it would just so happen to be that it would be 20t. Both 4, 5, and t would go into 20t. So what we're going to do is multiply each one of these fractions by that to simplify this problem. So I'm going to take this 20t and I'm going to multiply it here, and multiply it here. So let's do that and watch what happens. So I'm going to come in and let's multiply this by 20t, this one by 20t, and this one by 20t. Okay, so whenever you do that, the result is going to be 20t divided by 4 plus 20t divided by 5 is equal to 20t divided by t. And now that we've done that, what I'm going to do is come and simplify each one of these fractions. Well, 20t divided by 4, 20 and 4, those are, they have a common denominator. So you can actually divide 20 by 4 in this case, and it would leave you with 5 and now the t. Same thing here with the 20t and the 5. You'll notice that 20 and 5, that's reducible. 20 divided by 5 would be 4t. And then over to the side, the t's would cancel, leaving me with 20. And by doing this process, you'll notice how we've went from fractions to a regular algebra equation without fractions. And now I can add those together. 5t and 4t would be 9t equals 20. And of course, from here, everything's pretty straightforward. Divide by 9 and the 9's cancel. And I would get t is equal to 20 divided by 9. Or I could simplify that if we wanted to, if we want to put it in decimal form. But when you do that, you may get a fraction that you actually have to round on. In this case, if I did 20 divided by 9, it's going to be approximately 2.22, and it's going to continue repeating. So frequently we'll leave it as 20 over 9 because then we do not have to round. So that's how you solve a rational equation. It all comes down to identifying that least common denominator and then multiplying by that least common denominator up to each part as we did a few moments ago. So that's the basic trick. Okay, let's look at another one real quick and see how this would look in another situation. All right, so here's a second problem. You can see we have, again, a rational equation because it has fractions in it. On the left, you have x squared divided by x minus 3. On the right, you have 9 divided by x minus 3. Okay, so just like before, we're going to try to figure out the common denominator. Now, these, whenever you have a denominator that looks similar, this can sometimes be a little confusing because you have to apply some different strategies sometimes. The x minus 3, you have to recognize that that is one set. You cannot separate the x and the minus 3 from each other. And when we're talking about, like we did in the last problem, trying to get a common denominator, well, if you notice this, these denominators are the same. They're exactly the same right now. So I don't really have to do anything with this one. We already have common denominators. So if that's the case, what I can now do is focus on just the top, x squared equals 9, and solving that. And to solve that, of course, you get rid of a square by doing a square root. That's the opposite. And if I do that on both sides, square root and square would cancel, leaving me with x is equal to, now in this case right here, most people would come and put 3. But the thing you got to be careful for when you do square roots is remember that you have to consider the plus and the minus version of that. A positive 3 times a positive 3 is 9. A negative 3 times a negative 3 is 9. So both of those would be solutions. Now, here's the only catch. Whenever you're solving rational equations, something that you need to remember, very important, you need to always check your answer. Now, what I mean by that is you need to, whenever you're finished, plug your answer back into the original problem, see if there's any issues. The reason why you would need to do that, number one, is because of the fact that we have these fractions. And the thing that's special about that is anytime you have a fraction, remember there is one major rule in math, and that is you cannot divide by 0. So if I take any number and divide it by 0, that is a problem. Cannot do that, not possible. You can try it on your calculators, it will not work. So we have to make sure that we do not create a situation where we're dividing by 0. Okay, so here's how we're going to check that. I am going to take my answers. First one I have is a positive 3. So I have a positive 3 and I have a negative 3. Let's take the positive 3, plug it back in, see what happens. Well, if I do that into this whole problem, at the top left I would have 3 squared. Up under that, I would have 3 minus 3. Okay, right there I can stop instantly because I can already tell you 3 minus 3 is going to be a big old 0. And that's going to put me doing dividing by 0. Can't happen. That's a problem. So the fact that I tried to plug in a 3 is no good. So that part of the answer is definitely out. Okay? I don't know what happened there for a second. Anyway. So that part of the thing is absolutely out. So what I'm going to do is let's go and erase all of that part. Cannot do that. Now let's plug in the minus 3. So if I try plugging in a minus 3, then up here at the top left, that would be a negative 3 squared. On bottom, I would have a negative 3 minus 3 equals, on the right hand side, 9. Plugging in a negative 3 minus 3. Okay, so let's check that out. Up top, negative 3 squared is going to be 9. On the bottom, a negative 3 minus 3 is going to be a negative 6. And then let's check and see if it equals the right side. I do still have 9 there. And then on bottom, negative 3 minus 3 is a negative 6. So you can see the two sides match. And we're good to go. So the answer for this one is negative 3. The other one would not work. So again, make sure you're doing the least common denominator. That's the first part. Well, if I can get that right, least common denominator, solve it, then afterwards check your answer to make sure nothing weird happens. That's the big things about solving these rational equations. All right, let's try one more, and then we'll get over to the radical equations. Trying to keep these videos kind of short to the point, so let's check out and see what happens. Okay, here is our third problem. Now, first of all, just take a second to look at this problem. And at first glance, it just looks kind of like there's a lot of stuff going on. So let's break it down. It's definitely a rational equation. We have fractions, and we know that our strategy here is figuring out what is the least common denominator. So that means that I have to figure out between these different parts what is the least common denominator. Now, just looking at these, they look totally separate, look totally unique. You don't really see a lot of similarities in them. Also, what I notice is that each one has got 2 terms separated by either plus or minus. Now remember, we cannot isolate them. We can't break those apart. So in this case, it's helpful to do factoring. And factoring is that thing that not a lot of people, is their favorite thing, but it's also one of the most powerful tools we have in math. So what we need to do is, if I factor it, I can break it down into its parts so that I can see what makes up each piece. Now, in the first one, what I notice is that I have a 3 and a 6. And the first thing that comes to mind is greatest common factor. I can factor out a 3, and if I do, I would be left with x plus 2. Okay, the one at the very end, we really can't do anything there. That is just naturally x minus 2. There's no greatest common factor. Now, the one in the middle, this is what's called a difference, meaning subtraction, of two perfect squares. X squared is a perfect square, 4 is a perfect square. And the difference of squares rule for factoring is you make two groups of parentheses. One will be plus, one will be minus. Then x squared is the perfect square of x. 4 is the perfect square of 2. And then those are the two factors. Now that you've seen the parts and we've got it factored, you can see what makes up each piece. We can work on constructing this least common denominator. Least common denominator has to have all of the parts. So in this case, my least common denominator is going to have a 3 in it. It's going to have, let's make sure we got the 3 covered. I've got that covered here. There's no more 3's across here, so we're good. I have to have an x plus 2. So here we go. I'm going to put an x plus 2. By having that x plus 2 listed, I take care of it here. I take care of it here. And then I also have to have an x minus 2, which takes care of it here and here. Now I have all of the parts that are needed from the parts of my denominators. So now what I'm going to do is multiply that least common denominator to each numerator. Remember, that was what we started off with. So if I do that, then up top here I would have 3x plus 2, x minus 2 times 3, x plus 2, x minus 2, and times 3, x plus 2, x minus 2. Okay, so now let's simplify this. The first one is going to be 2 times all of that. Well, didn't mean to do that. 2 times all that, so 2 times the 3 would give me a... Actually, I'm not going to do that yet. I'm going to leave them separate. So let's go 2 times 3 times x plus 2, x minus 2, all divided by a denominator of 3, x plus 2, coming from right here. The next one is going to be plus 3, x plus 2, x minus 2, all divided by x plus 2. Whoop, something weird there. Let's try that again. I think I was writing too fast. X plus 2 and x minus 2 equals 4 times 3, x plus 2, x minus 2, all over x minus 2. Okay, so now let's see if we can clean any of this stuff up. So the 3's would cancel. I would have an x plus 2 cancels. Okay, so in that one, I'm left with 2 times x minus 2 plus x plus 2's cancel, x minus 2's cancel. So that's left with a 3. The next one, the x minus 2's will cancel, leaving me with 4 times 3, or 12 times x plus 2. Okay, so we now have a situation where we no longer have fractions, which is kind of was our goal. So now let's see if we can simplify. If I distribute the 2, I would have 2x minus 4 plus 3 equals, distribute the 12 would be 12x plus 24. Combine like terms here, so if I do, I would have 2x, a negative 4, and a positive 3 would be minus 1, equals 12x plus 24. Okay, so let's slide that up a little bit. Okay, now if we're going to solve, we need all our x's together on one side and our numbers on the opposite side. So I'm going to subtract this 2x over to here. Whoop. And then if I do that, that would cancel, leaving me with negative 1 is equal to 10x plus 24. Subtract the 24 over to the other side, and I want to get negative 25 is equal to 10x. And since this is being multiplied, I can divide to get rid of it. And, well, that would cross out. That thing does not like me for a minute. It's trying to predict what I'm trying to do. So here we go. And then that's going to be x is equal to negative 25 divided by 10 would be a negative 2.5. Now, don't forget, I told you a while ago, make sure that you're plugging into your answers and it's not going to create any issues. So let's try that back in our original problem that I have here in black up at the top. Okay, so we're going to plug our solution in negative 2.5 into each x spot. So let's see what happens when we do that. So I'm going to have 2 divided by 3 times negative 2.5 plus 6 plus 1 over negative 2.5 squared minus 4. And we're going to see, is that equal to 4 over negative 2.5 minus 2? Okay, so let's clean this up. So 3 times a negative 2.5 right here. 3 times negative 2.5. Well, that's going to be a negative 7.5 plus 6. Then I have 1 over 2.5 squared is 6.25 minus 4. And then here at the end, I have negative 2.5 minus 2, which is 4 divided by negative 4.5. All right, let's clean this up a little bit further. And if we do that, then I would have 2 divided by negative 7.5 plus 6 would be a negative 1.5. I'm going to go ahead and change that to a fraction, that negative 1.5. And the reason why is because in a minute it's going to make it a little bit easier for me to simplify that. So instead of negative 1.5, that would be the same thing as a negative 3 over 2. I'm just going to write it there to the side a minute so you can see it. Okay, the next one will be plus 1 over 6.25 minus 4 is going to be 2.25. And then here at the end, 4 divided by negative 4.5. And again, I'm going to convert both of those to fractions as well. 2.25 converted to a fraction is going to be 9 over 4. And let me write that here at the end. And negative 4.5 converted to a fraction is going to be, let me see, 9 over 2. Actually, negative 9 over 2. Okay, so here's why I want to do this. This kind of helps deal with the decimals. Instead of dividing by a fraction, dividing by these blue parts, there's a rule in math that says instead of dividing by a fraction, you can multiply by its reciprocal. So 2 divided by a negative 3 over 2 is the same thing as 2 times its reciprocal, which would be 2 over negative 3, plus 1, instead of 1 divided by 9 over 4, would be 1 times the reciprocal, 4 over 9. It's much easier to deal with multiplication than division usually. And then at the end is 4, not divided by negative 9 over 2, but times its reciprocal, 2 over negative 9. Now, the reason this makes it easy is because now I can just multiply. 2 times 2 is 4, divided by 3. I move the negative to the top, plus 4 over 9. And we're going to see, is that equal to 4? Well, 4 times 2 would be 8 over 9. So negative 4 over 3 plus 4 over 9. Well, let's get this one a common denominator here, just like before. So if I multiply times 3, then that would be a negative 12 over 9 plus 4 over 9. Is that equal to negative 8 over 9? Well, let's check it out. Negative 12 and 4 would be a negative 8 divided by 9, and look at that. We are now the same. So that's one way you can check it. You could also just plug it in on your calculator and check whenever you're doing this. So the point is, whenever you're doing these, one, the least common denominator, you're definitely still going to have to do that. Sometimes you're going to have to factor and then make sure you're plugging back in at the end. But that is the process for solving these rational equations. Okay, so part 2 is doing the radical equations. They're not quite as involved as the rational equations. So let's go ahead and get this cleaned up, and then we'll start with the radical equations. Okay, so radical equations basically means that it has some kind of a root in it, like a square root, it could be a cube root, it could be a fourth root, so on and so on. Now let's start this kind of simple. So let's suppose I have that the square root of x is equal to 16. Well, the method for solving square root or radical equations is basically the same as every other algebra equation. The only exception is making sure you know how to get rid of the radical. And to cancel it out, the opposite is to do its power. In this case, since I have a square root, then to cancel that, I'm going to square both sides, which means that the square root and the square would cancel, leaving me with x is equal to 16 squared. 16 squared is going to be 256. Okay, and that's basically it for radical equations. It's really that simple. Now, sometimes they can get a little bit more long or longer, but that's the essence of it. And of course, you could plug it back in to verify square root of 256 is going to be 16. Okay, so now let's try one that's a little bit more involved, but not too much. I'm going to try square root of 3x plus 1 is equal to 4. Now, just like before, to isolate the x, to get x by itself, we need to get rid of the radical. Opposite of square root is to square both sides. So that would cancel, leaving me with 3x plus 1 is equal to 4 squared, or 16. Now, it works just like usual. Subtract 1 from both sides. I have 3x is equal to 15. Divide by 3, and you would have x is equal to 5. Of course, you can plug it back in just to verify. 3 times 5 is 15. 15 plus 1 would be 16. And then the square root of 16 is indeed 4. So there you go. That is how you do radical equations.